Ever wondered how data is organized and managed in databases and applications? Welcome to the intriguing world of data models. These are conceptual representations that help us understand the structure, relationships, constraints, and semantics of data within a specific context. They serve as blueprints for designing databases, applications, and systems that handle data optimally. Data models come in different types, each with its unique strengths and purposes. We have the hierarchical, network, relational, entity relationship, object-oriented, document, and graph data models. These models range from representing data in tree-like structures, organizing data into tables, extending object-oriented programming concepts to data management, to representing data as nodes and edges in a graph structure. The choice of data model depends on various factors like the nature of the data, application requirements, performance considerations, and scalability needs. So, are you ready to dive deeper? Let's dive into the fascinating world of data models. First up, we have the hierarchical data model. This model presents data in a tree-like structure, creating parent-child relationships. In this structure, each parent can have multiple children, but interestingly, each child has only one parent. This one-to-many relationship is a characteristic feature of the hierarchical data model. Originally, this model was commonly used in older database systems, offering an organized, logical, and intuitive way to store and retrieve data. Despite its age, the hierarchical data model is far from obsolete. It has found a place in the modern data world, particularly in hierarchical data formats like XML. XML, or Extensible Markup Language, utilizes the hierarchical data model's tree-like structure to store and transport data. This model's influence on XML is a testament to its lasting relevance and adaptability. Though it's an older model, its influence can still be seen in modern data formats like XML. Moving on, we have the network data model. This model takes the hierarchical structure a step further by allowing a child to have multiple parents. Imagine a web of interconnected records rather than a tree. This is achieved through the use of pointers or references that establish relationships between records. The network data model is a bit like a family tree that acknowledges all relations, not just the paternal or maternal line. It's a more realistic representation of many real-world situations. For instance, in a business setting, an employee could belong to several departments, not just one. But with this flexibility comes complexity. Managing and navigating this network of data can be challenging. Understanding the relationships and maintaining the integrity of the data requires careful planning and robust systems. But don't let that intimidate you. When used correctly, the network data model can be a powerful tool for representing complex interrelationships. Despite its complexity, the network data model provides a high level of flexibility. Next, we step into the world of the relational data model. This model organizes data into a tabular form, with each table or relation consisting of rows and columns. Rows, also known as tuples, represent individual records, while columns or attributes define the characteristics of these records. Keys, such as primary and foreign keys, serve to establish relationships between these tables. The beauty of the relational data model lies in its operations, which are based on set theory. Selection, projection, join, and union become powerful tools in the hands of database administrators, enabling them to manipulate data effectively. This model is not just theoretical, it's at the heart of many modern database management systems. Whether you're working with MySQL, PostgreSQL, Oracle, or SQL Server, you're leveraging the principles of the relational data model. So, in essence, the relational data model is a cornerstone in the world of modern databases. Now let's talk about the entity relationship model. This model, often abbreviated as ER model, is a high-level conceptual data model that showcases the relationships between different entities within a system. An entity in this context can be a real-world object or concept, such as a customer in a retail database or a book in a library system. Each entity is characterized by its attributes, which are properties that provide more information about the entity. For instance, a customer entity might have attributes like name, address, and contact details. Now, relationships are the ties that bind these entities together. They illustrate how one entity relates to another. For example, a customer can purchase a product, establishing a relationship between these two entities. To visually represent this model, we use something called an Entity Relationship Diagram, or ERD. These diagrams provide a clear visual representation of the data structure, making it easier for database administrators to design and manage complex databases. The entity relationship model is an intuitive and visual way to represent complex data structures. Let's dig into the object-oriented data model. This model takes the principles of object-oriented programming and applies them to data management. Here, data is represented as objects, each having attributes and methods, much like classes in object-oriented programming languages. This model introduces concepts such as inheritance, where an object can inherit properties from another object, encapsulation, which guards an object's data from outside interference, and polymorphism, allowing objects to take on many forms based on context. Its real power lies in its ability to model complex real-world situations effectively, with objects mirroring real-world entities. The object-oriented data model is employed in object-oriented database management systems, often abbreviated as ODBMS, and object relational mapping frameworks. These systems use the model's principles to provide robust, flexible data management solutions, capable of handling complex data relationships and operations. The object-oriented data model brings the power of object-oriented programming to data management. Next, we explore the document data model. This model is a unique beast known for its ability to handle semi-structured data, like JavaScript object notation or JSON, and XML documents. It's a bit like a digital filing cabinet, storing information in documents that contain nested key-value pairs or hierarchical structures. What makes the document data model stand out is its flexible schema design. This means that within the same collection or table, documents can have varying structures. It's a bit like having a filing cabinet where each drawer can store different types of files without any fuss. This model is a favorite among NoSQL databases, such as MongoDB and Couchbase, and is ideal for use cases where data doesn't fit neatly into tables. It's the go-to for handling data that's a bit more complex and less uniform. The document data model offers a flexible approach to managing semi-structured data. Finally, we delve into the graph data model. This model stands apart in its unique way of representing data as nodes or vertices and edges or relationships in a graph structure. Nodes in this model represent entities, while edges illustrate the relationships between these entities. Picture this: in a social network, individuals would be nodes and their friendships would be the edges. The graph data model shines in its ability to efficiently traverse and query complex relationships and networks. This makes it a go-to model for applications that need to analyze interconnected data, from social networks to recommendation engines. You'll find this data model utilized in graph databases like Neo4j and Amazon Neptune. These databases are designed to handle data that's interconnected in many-to-many relationships, a task that can be challenging for other models. The graph data model excels at managing complex relationships and networks. All these data models have their strengths and weaknesses. We've been on a journey through the world of data models, exploring their various forms and functions. And it's time to conclude and recap. We started with the hierarchical data model, reminiscent of a family tree with its parent-child relationships. This model's strength lies in its simplicity, but it can be a little limiting as each child can only have one parent. Next, we ventured into the network data model, a more complex structure that allows each child to have multiple parents. This model offers flexibility, but this flexibility can also lead to complexity in management. We then moved on to the popular relational data model, which organizes data into tables, making it easier to manage and manipulate. This model's power lies in its foundation on set theory, enabling operations such as selection, projection, join, and union. The entity relationship model was up next, representing data using entities, attributes, and relationships. This model provides a clear visual understanding of the data structure by using diagrams such as entity relationship diagrams. Our journey then took us to the object-oriented data model, which brings the concepts of object-oriented programming to data management. It's a model that's rich in concepts like inheritance, encapsulation, and polymorphism. The document data model was next on our list, a model perfect for handling semi-structured data like JSON or XML documents. This model is known for its flexible schema design, allowing for variations within the same collection or table. Finally, we explored the graph data model, which represents data as nodes and edges in a graph structure. This model is exceptional for handling complex relationships and networks. So we've seen that each data model has its own unique qualities, its advantages, and its drawbacks. The choice of a data model isn't a one-size-fits-all situation. It's a decision that needs to be made based on the nature of your data, the requirements of your application, performance considerations, and scalability needs. Remember, the choice of data model depends on your specific needs and the nature of your data, so choose wisely.